In this video, we are going to talk about linear equations, the way they appear on the IB exam. Important things for you to remember. First of all, we have what's called a coordinate plane. A coordinate plane has two axes, the x-axis and the y-axis. It is split up into 4 quadrants, which we number counterclockwise. So 1, 2, 3, 4, using Roman numerals. In quadrant 1, both of these x and y coordinates are going to be positive. So the point 1, 4, it's a positive 1 and positive 4. Every ordered pair is x, y. This is something you should remember from Algebra 1. And it's ordered pair because in the English alphabet, x comes before y. When we go to the second quadrant, then you have negative x's and positive y's. So if I have a point like negative 2, 1, notice that the x is going to be negative and the y is positive. When we get to the third quadrant, then we have both negative, negative. So if I have negative 1, negative 4, this is the point negative 1, negative 4. It's negative 1 on the x-axis and negative 4 on the y-axis. Then in the fourth quadrant, I have positive 4 and negative 1. Your x-coordinate is positive and your y-coordinate is negative. So these are the basics of what you need to remember about the coordinate plane. We're going to move on to a linear equation. Y equals mx plus c used to be y equals mx plus b when you did this in Algebra 2, but for IB, you're going to see it in the formula booklet as y equals mx plus c. Now, things haven't changed. M is still your slope. The only difference is that for IB, we're going to call this the gradient. So it's no longer going to be called slope, it's going to be called gradient. And C is still my y-intercept. So as long as the y is by itself, let's say we have y equals negative 2/3 x plus 1. As long as the y is by itself, then the number that's next to the x is going to be your slope, which for IB is going to be called gradient. And then here we have a y-intercept of 1. This means that first I have to go to my y-axis and I'm going to plot the point 0, 1. From here, I'm going to follow the slope, the gradient. Because it's negative 2/3, I can go down 2, right 3, or I could go up and left. The idea is that when you go down, you take care of the negative and then write positive. Negative divided by a positive is a negative. So I go down 1, 2, and over 1, 2, 3. Okay, so right here, I'm going to have my point when I went down 2/3. So once I have these 2 points, I can go ahead and connect these with a line. When the line is rising from left to right, we say that it has a positive slope. When the line is falling from left to right, we say it has a negative slope. When the line is horizontal, we have a slope of 0, a gradient of 0. And when the line is vertical, we say that the slope is undefined or that there is no slope. The equation of a horizontal and vertical line are a little different. For the horizontal line, since we know that y equals mx plus c and the slope is 0, I would have y equals 0x plus c, which really means that we're going to be left with y equals c, or in other words, y is just equal to a number. So when you see an equation like y equals 4, y equals -5, that is just going to be a horizontal equation. One of the things that I always tell my students is think about the word horizontal. Notice that there are zeros in the word horizontal. When we move on to a vertical line, notice there are no zeros in the word vertical. And so here, my slope is undefined. That is just something to try to help you to remember. Horizontal line, slope is 0. Vertical line, undefined slope. Okay, if it helps you, great. And if it doesn't, then stick to what you know. So here for the equation of a vertical line, it's just going to be x equal some number. So if all you see is x equals 4, x equals -1/2, It is just going to be a vertical line. Back in the graph, if I were to add the equation x equals -2, it is going to be a vertical line passing through -2. So I'm just going to go ahead and draw this line at -2. It's nice that on the iPad, it makes it a straight line. If I have the equation y equals -2 instead of x equals -2, now that's going to be a horizontal line that's going to cross at -2 on the y-axis because y equals -2. So here is my horizontal line. Vertical line is perpendicular to a horizontal line. There are other forms of the equation of a line. One of them is point slope form, or now for IB purposes, it's going to be called the point gradient form. The point gradient form is y minus y1 equals m times x minus x1. Let's say they give us a question where it tells us find the equation of a line that passes through the point -4, 7 with a slope of 1/2, with a gradient of 1/2. I could put this into y equals mx plus c form. I could solve for the y-intercept, but it's going to be a little bit of work. Here, if they haven't told me exactly which form they want, I can just go ahead and put it in point slope. For point slope, what I'm going to replace is y1, my gradient, and x1. So the point they give me is x1, y1. Remember, every point is an ordered pair, x before y, and of course the gradient is 1/2. So I would write y minus y1, which is 7, equals 1/2 x minus, because it is subtraction and the 4 happens to be negative. So this means that y minus 7 is equal to 1/2 times, and then of course negative times the negative is a positive, x plus 4. And this is the equation of your line in point gradient form. Can I change this to y equals mx plus c form, which is called our gradient intercept form? It's what used to be called slope-intercept form. So now it's gradient intercept form. And the answer is yes. If you want to get the y by itself, you're going to have to distribute and then combine like terms. So y minus 7 is equal to 1/2 x plus 1/2 of 4 is 2. Add 7 to both sides. You get y equals 1/2 x plus 9. So this would be your answer in what's called gradient intercept form. However, had the question on the quiz or the exam not asked you for a particular form, they would have accepted the point slope form answer as your final answer. Some students prefer to go straight into y equals mx plus c form, and that is perfectly fine. If that is the case, and we are not going to be using the point gradient form at all, then what you want to do is call this x, y, and of course, we know that this is going to be our slope, our gradient. So I'm going to replace it, and I'm going to put 7 equals 1/2 of x, which is -4, plus c. 7 equals -2 plus c. If I add 2 to both sides, I get 9 is equal to c. That means that I have found the y-intercept. Then I can write my final answer as y equals 1/2 x plus 9. There is another form that you need to be made aware of. Remember, we have the point gradient form, which is point slope form, which is y minus y1 is equal to m times x minus x1. We also have the slope-intercept form, which is the gradient intercept form, because remember the word gradient is used for slope. So gradient intercept form, and that's y equals mx plus c, but there's one more, which is our standard form, or sometimes they refer to it as general form. Okay, so it depends on the wording of the question, but this one does look a little differently. It's ax plus by plus d equals 0, and these are all in your formula booklet for the math applications course. In this case, you want to make sure that your x is positive, or you can say your a is positive, whatever that coefficient is for x, okay? It has to be positive. There can be no fractions or decimals, and it has to be set equal to 0. This is a little different from algebra 2. In algebra 2, you learned this as ax plus by is equal to c. But in this case, notice for IB, it's going to be set equal to 0 instead. So let's take a look at an example. Let's say we have y equals 1/2 x plus 9. This is clearly not written in this general standard form because I'm supposed to have x positive, which yes, that is true. However, there can be no fractions or decimals. I clearly see a fraction in the problem, and it has to be set equal to 0, which is definitely not. One of the first things I'm going to do is decide to get rid of the fraction altogether. And so I multiply the entire equation by the least common denominator. Here, there's only one denominator, so you're going to multiply the entire thing by 2. 2y is equal to 2 times 1/2 is 1, x plus 18. So now my x is positive. I have no fractions or decimals. I have to set it equal to 0. And because I want to keep my x positive, I'm not going to move it. Instead, I'm going to move the 2y over. And then finally, I'm going to write it in that same general form that we have just talked about. So I'm going to write x minus 2y plus 18 equals 0. Something else that we have to review is how to find the x and y intercept of a line. To find the x-intercept, you're going to set y equal to 0. And to find the y-intercept, you're going to set x equal to 0, okay? So if we take a look just at a random example, let's say I have negative 2x plus 3y is equal to negative 6. If I want to find the x-intercept, then what I'm going to do is set y equal to 0. That means negative 2x plus 3 times 0 is equal to negative 6. Negative 2x is equal to negative 6. If we divide by negative 2, that means that x is equal to 3. So my x-intercept is the point 3, 0. If I want to find the y-intercept, now I'm going to set x equal to 0. So I'm going to have negative 2 times 0 plus 3y equals negative 6. Of course, negative 2 times 0 is just 0. So I'm left with 3y equals negative 6. Divide by 3. And I'm going to get y is equal to negative 2. Because this is the y-intercept, I'm going to get 0, negative 2. So here is my x-intercept and my y-intercept. And one of the things that you do not want to do is write your final answer as the point 3, negative 2. This is a big no. Don't do that because they're two separate points. And of course, last but not least, we cannot forget to talk about parallel lines and perpendicular lines. Parallel lines are lines that do not intersect. Parallel lines have the same slope, okay? They have the same gradient, but they're going to have different y-intercepts. If they don't have different y-intercepts, then obviously they're the same line. So they have to have different y-intercepts, but they have the same slope. Because slope is rate of change, rise over run, they're going to be constantly rising and running at the same time. So those are parallel lines. Then perpendicular lines are lines that cross in such a way that they form a perfect 90-degree angle. You have to be careful between intersecting lines and perpendicular lines. Intersecting lines just are lines that cross. They can cross in any which way, but they are going to be perpendicular when they cross to make a perfect 90-degree angle. So these are perpendicular lines. When you learned this in geometry, there was a symbol for perpendicular lines, which is the upside down T. Okay, so that's the perpendicular line symbol. And one of the things that we know about the slopes of perpendicular lines is that if I multiply the first slope with the perpendicular line slope, the product of the two slopes is -1. This means that if my slope is 1/4, then my perpendicular slope is going to be the negative reciprocal. You flip it and change the sign. So it'll be -4/1. So that is called the negative reciprocal. I know some of you probably learned it as opposite reciprocal, and that is fine. And the idea is that when you multiply the two slopes together, you're going to see that it's going to equal -1. So the product of two slopes, if it's equal to -1, I know that it's going to be perpendicular. And that's where the idea of the negative reciprocal comes in. Be careful with values like, let's say they give you a whole number. If the slope of one line is 5, what's the perpendicular slope? You have to remember it's not -5. And a good way to check is 5 times -5 is -25. It's supposed to give me -1, and it doesn't. You have to remember 5 is 5 over 1. So the perpendicular slope is going to be -1 over 5.